Welcome to podcast number 3, molar mass conversions. These conversions will be some of the most common calculations you do in chemistry. And there are 2 learning targets covered in this podcast. They're very closely related. The first is learning target number 4, where if you're given the number of moles of a substance, you should find the number of grams. Learning target number 5, which we'll see in a little bit, is the reverse of this. In the previous podcast on molar mass, we found these molar masses. You want to write these 3 relationships in your notes because we will use these molar masses as this podcast progresses. So please write down 1 mole of aluminum equals 26.98 grams of aluminum. Write down in your notes 1 mole of O2 equals 32.00 grams of O2. And write in your notes 1 mole of Na2SO4 equals 142.02 grams of Na2SO4. Let's take a look at how we will proceed in working out these problems. You have 3.2 moles of aluminum. How many grams is this? Well, to do this problem, we want to remind ourselves about one of the relationships we just jotted down. We know that 1 mole of aluminum equals 26.98 grams of aluminum. And we're going to make use of that equivalence statement as we work out this problem. So let's start with the term that has the numerical value in our question, 3.2 moles of aluminum. Dimensional analysis will make the solution of this problem very straightforward. We're going to use this equivalence statement, and remember, dimensional analysis has us canceling units, so since we have moles of aluminum here, we want moles of aluminum here. We have a relationship here between moles of aluminum and grams of aluminum. We can put in our numbers. Notice how our units cancel. That tells us that the units on our answer are grams of aluminum, which is what we're interested in. Now when I do this on my calculator, I get 86.336. Now here's where significant figures comes into play. Remember we said that for our equivalence statements, these numbers will have an infinite number of sig figs. So for us, this number 1 has an infinite number of sig figs, as does 26.98. So the term we're going to use to determine how many sig figs in our answer is this first number over here, which has 2 significant figures. So what we're going to do is take a look at the number that we wrote down a moment ago, 86.336, and round this off to 2 significant figures. We'll have 86. Since this number here is a 3, the 6 remains a 6, so our answer then is 86 grams of aluminum. Let's try another. It says we have 1.821 moles of oxygen. How many grams is this? Again, let's remind ourselves of the relationship we wrote down a little bit ago. 1 mole of O2 has a molar mass of 32.00 grams of O2. Grams. So let me write down the number and the units for this problem. 1.821 moles of oxygen. We're going to use dimensional analysis to help us through this. We have moles of oxygen here, so we have to put moles of oxygen here. We have a relationship between moles and grams, so I can put grams of oxygen up here. I can put my numbers in. My units cancel out here. So the unit on my answer is going to be grams of O2. That's good because that's what I'm looking for. When I do this on my calculator, I get 58.272. Now I have to bring significant figures into play. These numbers have an infinite number of sig figs. This number has 4 sig figs. So if I go over 4 sig figs, this number is a 2, so the 7 will remain a 7. So my answer here will be 58.27 grams of oxygen. And that then is our answer. With that, we'll move on to learning target number 5, which is actually the reverse of learning target number 4. For learning target number 5, if we give you the number of grams of a substance, you need to be able to find the number of moles. Let's see how that's done. We have 2.31 grams of aluminum, and we want to know how many moles this is. So let's remind ourselves of the relationship between moles and grams of aluminum. 1 mole of aluminum is equal to 26.98 grams of aluminum. So if we start out the same way we did before, with 2.31 grams of aluminum, and if we allow dimensional analysis to help us through this, because we have grams of aluminum here, we have to put grams of aluminum here. Because we want our units to cancel, we'll put moles of aluminum here. 1 goes in front of the word moles, and 26.98 goes in front of the word grams. And we do our math. When I do this on my calculator, I get 0.085618.9. These numbers have an infinite number of sig figs. This one has 3, so I want to count over 3 sig figs. That's a 1, so the 6 remains a 6. So my answer will be 0.0856 moles of aluminum. Easy because of dimensional analysis. Let's practice with another similar kind of question. We have 57 grams of oxygen. We want to know how many moles this is. So let's remind ourselves about the relationship between moles of O2 and grams of O2. 1 mole of O2 is 32.00 grams of O2. Let's write down our number. We'll use dimensional analysis to guide us along. So That means I have to put grams of O2 in the denominator so that these units cancel. I have a relationship between grams and moles, so I can put moles of O2 up here. 1 mole of O2 is 32.00 grams of O2. When I do this on my calculator, I get 1.79375. Now I want 2 sig figs in my answer. Now this number here is a 9, so that's going to boost my 7 up to an 8. So I will have 1.8 moles of O2 as my answer. Let's do one more question. We want to know how many moles 48.2 grams of Na2SO4 is. Well, we wrote down a while ago that 1 mole of Na2SO4, that's a 4, I hope, equals 142.02 grams of Na2SO4. So let's start by writing down 48.2 grams of Na2SO4. And let's let dimensional analysis guide us along. So I have to put grams of Na2SO4 here. I have to put moles of Na2SO4 here so that my units cancel. 1 mole of Na2SO4 is equal to 142.02 grams. When I do this on my calculator, I get 0.3393888. I want 3 significant figures in my answer. So this number is a 3, so this will remain 0.339 moles of Na2SO4. And there we have it. Please go to page 23 of your packet and practice changing between grams of a substance and moles of a substance.